Don't worry.
Okay, sir.
Sure. Okay. Uh, Fine. So now the thing that I will discuss, maybe it is not required for you in this week, and maybe a few of you are not answering, but maybe still many of you might know, or it might so happen that many of you might not know. So anyway, but this is important for the course, and this will not explicitly be discussed in any week. So that's why I feel it is important to know a few basic stuffs for your better understanding in the next part of the course. See, DBMS will be I don't know whether it has been mentioned in your first session or not, but it will be a really computer internals as well as the main concepts of DBMS will obviously be discussed in a lot of depth. But the thing is, a lot of computer internals also has to be known in order to do the course properly, understand all the aspects of it. So all those things are there. So this is how basically there are few points that we need to discuss. I will do that. So I want you guys to answer a lot of question in this session. Okay, so please be interactive because as many of you are not aware of things, so I must know what you are aware of, what you are not. So please be interactive. Please ask a lot of question, and if I ask something, please tell. Okay, it's fine. So see how basically we divide a computer is we have uh, basically a memory part where I store things, and then again we have a processing part where the computer basically solves the computation or does the computation. Now the memory part is what we call again further divided into, not what we call memory part is again further divided into, basically crudely speaking there are much more integrated details into this, but basically it is divided into two separate units. One is called the memory is again divided into two separate units. One is called your secondary memory, S memory, right? Another is your primary memory, P memory. Fine. And your computation part is basically your processor. Actually, two things are there. Let me write it for mentioning. But in this course, we will not need the other branch. I mean this branch, which is your graphical processing units or GPUs. Fine. So mainly these two are your computational part in a normal computer, and memory has primary and secondary memory. So what is secondary memory? Secondary memory is basically your hard disk. Okay, and if any other USB pen drive, all those external devices, peripheral devices. But since I am not discussing now peripheral devices, mainly it is hard disk. Okay, and the primary memory is basically your RAM. Okay, so random access memory. RAM. So all of us know RAM. So this is your primary memory. What is the difference between secondary and primary memory? So primary memory, once the computer switches off, maybe due to power failure, maybe you shut it down, whatever it is, primary memory will be erased. Okay. So this will be erased when computer turns off. Okay, by the way, since I will be discussing these topics, I will not be able to see who is raising your hand. So directly switch off your mic and go on. Ask something if you want to ask.
Sir, where is ROM stored, sir? In
Ah,
secondary or
good question. Good question. I will come to that. Come to that. Fine. So erased when computer turn off, and this is persistent. So data what is stored in a hard disk will be persistent even if your power goes off, if you switch off the computer, whatever it is. So the songs you store in your computer, let's say who are using Windows, and I assume most of you are using Windows. So your C drive and your D drive, C drive, whatever, like all those drives. So that things remains, right? So that is stored in your hard disk. That's why it is persistent. But RAM, once it any primary memory unit, when once the power goes off, it will be erased. So then what is the use of this primary memory? I mean, why do we use RAM then? What is the main, I mean, why do we need RAM? If it is getting erased, the main motive behind having a memory is you need to store something in the memory and it should be there. And that is why you have a memory, right? We call it a memory because you retain something in it. That's why we call it memory. But if RAM is forgetting things when the computer turns off, then why is it required? Now,
It is faster
Because
than
faster than the
Masters.
correct, correct. So, so it is faster. RAM is a much, or primary memory RAM is a much faster memory, faster hardware. Okay, and this is much as slower hardware. And because of this, since RAM is much faster hardware, processor speed, right? Your computation unit, which is your processor, right? Your processor is very high speed. Very high speed. Right. Now, since your processor is very high speed, therefore, if your memory is slow, what happens is whenever you compute something, what is computation? So what do you mean by computation? What does this word mean? Computation means basically you are picking up data or some pre-stored stuff from your memory. You are picking that up, picking some information or data or whatever, your programs, your songs, your music, whatever you are doing something, right? Whenever you, let's say you play a music, right? What happens actually behind the scenes? You go to your hard disk, right? Basically, maybe D drive. You go to your D drive, and inside your D drive, which is basically your hard disk, you just double click on a song, and then your Windows Media Player or whatever player you have, it starts playing. So how does it happen behind the scene? So the song at first is stored in your D drive, which is basically your hard disk. Fine. So it is stored in hard disk. As soon as you do a double click on the song, what happens is your, since it is also a computation, you may say that, okay, the song is already stored, so what are we computing? But that's not it. Once you are actually playing a song, it has to be, I mean, it has to be converted into an intermediate form, and that has to be again sent to the media player in a way, and the media player will then start playing it, which has to be converted into electrical signal, and that has to be sent to your speaker unit of your computer. Or let's say if you are hearing it on Bluetooth, then it will be sent to the Bluetooth unit, and then Bluetooth will also forward it to the connected device. So all this, there are a lot of things going on behind the scenes. So what I mean is you don't have to worry about all of that. What I mean is even when you are just playing a song, there are a few computations which are needed. It's not that when we only do some mathematical work or quantitative work, then only computations will happen. Even playing a song requires some processor time, a little bit of processor time, but it is required. Even if a little bit, then but still it is required. So the main part is whenever any computation occurs, or let's say when you play a song or something like that, at first it will be in the hard disk. As soon as you do a double click on the song, it will be copied, right? The song will be copied into your RAM. Okay, only the song, not all the songs in that hard disk drive, right? Only that song will be copied to your RAM at a specific area of the RAM. Now inside the RAM, I mean, it will be remaining in the RAM, and then your processor will ask data from the RAM. Why? Because your processor can only interact with RAM, only interact with RAM. Okay, your processor cannot interact with hard disk. It doesn't even know. Actually, if you ask the processor, I mean, you ask means I'm talking in that sense that if you somehow want to ping the processor that tell me your any information about this hard disk drive, processor doesn't know it. For the processor, there is only one memory, and that is the RAM. It doesn't know the existence of hard disk. RAM knows the existence of hard disk. So RAM and hard disk will communicate within themselves. But processor doesn't know hard disk. Processor only knows that there is only one memory, and that is RAM, and whatever I need, I will ask the RAM. If I need to do a computation or whatever, I will ask the RAM to send me the data regarding it. Okay, so processor will put a request to your RAM. RAM will send the song which is now copied from hard disk inside your RAM, and then RAM will be sending it to your processor for further computation, which is basically in this case playing that music. So this is what's happening behind the scene. Whenever you do some task on your computer, nothing happens directly from your hard disk. Everything will be copied to your RAM, and then RAM will send it to your processor for further things to be done. Okay, this is how it is. Now, why is this done? Why is this whole process? Why can't we send directly from processor and hard disk and vice versa? Right? Why can't processor directly interface with hard disk and ask whatever it is needed? Right. So the thing is that many of you answered that processor is a sorry, RAM is a much faster memory unit and hard disk is a much slower memory unit. Now again, so fine. Do we? I mean, it is fine, but what is the main need for a faster memory unit? Now the thing is, processor is very high speed, right? Now let's say in a class, a teacher is teaching so fast that the students are not understanding anything. So ultimately, it doesn't work, right? So I mean, nothing will happen. Nothing good will come out of that classroom. Also the other way around, let's say the students are super really brilliant and somehow the teacher who is teaching, he is not that much aware of his subject, so then also nothing will come out of that classroom. So either way, I mean, it has to be good on not good, it has to be on equal standards, right? If both of them are attentive, if both of the teacher as well as the students are attentive, then only something good will happen in the class. So something like that is happening over here. Unless and until you have a faster memory unit to cater to the demands of the processor, your computation will not be done in a good way. And likewise, even if the processor is not good and memory is faster, then also computation will not be done in a good way. But the thing is, processors are very fast devices because of the electronics behind the processors, and it is much faster than any memory unit. Okay, and that's why in order to cater to the fast demands of processor, we need to have a faster unit of memory, and that faster unit of memory is your random access memory, RAM. And this is the main reason we need a RAM. So everything you do in your computer, it will be first copied from your hard disk into your RAM, and then inside the RAM it will remain. Processor will ask the RAM, because processor doesn't know what hard disk is. It will only interface with RAM and ask whatever is needed. RAM will send it to the processor. Now let's say processor asks something which is maybe not at that point, it is not in the RAM, right? Processor is asking, because for processor the thing is, let's say, let me give you an example in such a way. You are watching a movie, and that movie is a, let's say, Blu-ray kind of very high quality movie. Okay, very high quality movie, and it is huge in space. Let's say it is 12 GB in space, and your RAM space is much lesser than that. Okay, now you double click on the movie. It will take some time. After some buffering, maybe then it will start working. You will see on the media player it is running. So fine, that is okay. But then let's say sometimes in between it will always start buffering. It will always take some time. Now there are some many reasons behind it, but one of the major reason can be that whenever the processor is demanding the RAM, that okay, send me the next part of the movie, it might so happen that the RAM has yet not fetched that data from hard disk. Okay, because the movie is mainly residing in your hard disk. RAM is fetching that data from hard disk inside the RAM and sending it to the processor, because RAM supplies the data to the processor in a faster way than hard disk can ever do. That's why RAMs are used. Now let's say processor is asking for the next part of the movie to be played, but RAM doesn't have that at this point, because the movie is huge and it could not copy the whole movie from hard disk inside the RAM. The song was fine. The whole song was copied at first inside the RAM, and then only processor, one by one it was sent to, I mean, sorry, not one by one, I mean part by part of the song was sent to the processor and it was playing. But this movie is huge and it is not completely copied inside the RAM, because RAM is much smaller. It is faster, but RAM is much smaller in size than your hard disk, right? So in that case, let's say a processor is asking the next part which is not inside RAM, and then RAM again has to put a request to the hard disk that send me the data, and then the data will be sent to the RAM, and then again the processor will be acknowledged it by its request, right? So there will be some buffering because of this, because processor is asking the data and RAM doesn't have it, so RAM has to ask the hard disk. Now one important point is this interfacing, right? This area of interfacing is very slow. Is very slow means it is slow, not very slow, but what I mean is compared to this interaction, RAM and processor, which is very fast, the interaction between RAM and hard disk is slow. So this is one very important point with respect to your course, which will be realized in your further weeks, that secondary memory interfacing, secondary memory interfacing is very slow. So when I say very slow, this interfacing, right, processor to RAM interfacing will be in ranges of maybe sometimes in nanoseconds also. Okay, I mean 10 to the power minus 9 seconds. In this range also this interaction will happen. And your this interaction, RAM hard disk interaction may even take milliseconds, right, which is I think 10 to the power minus 3. So you see the orders of magnitude difference between these two interactions. So milliseconds and seconds, this is how things will work. So that's why this interaction is much slower as compared to RAM and processor interaction. So whenever we have to deal with stuff between secondary memory and primary memory, that is a huge starvation point. Starvation point means you will starve, you will wait for the things to come into place. The processor has to wait. Okay. So this is one fundamental idea. And now let's also introduce the operating system behind it. Now how operating system works. All this we are talking, right? Computation, processor, hard disk, RAM, all of these are hardware. Now hardware is just like the body, as many of you know. Software is the soul of the machine. This is a common definition, many of us heard about it. Now the software over here is the operating system. Operating system will interact with the hardwares, as I think one of you also wrote in the chat. So it will interface between the hardware and the upper levels of the software, right? And it will basically whatever is required, because at the end of the day everything happens in the hardware. But when you are writing a Python code or whatever code you are writing, right, you are not writing keeping in mind what the hardware is, how the hardware is working. You are not worried about all of that. So there is a lot of abstraction between you and the actual way the things are working behind the scene. So that's why to cater to that abstraction, the main thing which does it is your operating system. So it will take the request from the application level software. Application level softwares are what? Basically your apps and all these, your, let's say your Microsoft Excel, whatever, like all this, the text editor and that I'm currently using, all of these things, all these things are, or whiteboard software, whatever you call it. So all these things are application level software. Operating system will take the request from this application level software, convert it into a form understandable by the hardware, and then send it to the hardware. So for, let's say, take an example. I am writing on this whiteboard application by using a pen tab. So how is it happening? There is a lot of things working behind the scene. When I'm putting my pen on the pen tab, it is generating a particular signal at this value of the, at this coordinate of the screen. Now, but before the dot is displayed on the screen, within, in nanoseconds, whenever I'm touching the dot on the pen tab, let's say I touch this dot on the pen tab, okay, this particular area, it gets converted into a signal. It goes inside the computer. Operating system takes that signal, converts it into a form. At first it judges that what is the screen position corresponding to this signal. So what is the coordinate in the screen, sorry, on the screen where the dot should be displayed. That computation is done by operating system. Now computation is done by the operating system means what? Operating system cannot itself do computation. It will need the processor, right? So operating system will send the request to the processor. Okay, so this signal has come from a pen tab. Now I want that what is the exact location on the screen, on my computer screen, on my monitor, where this signal corresponds to, where this dot should come, right? So processor will execute its softwares, and it will understand, it will do the computation, it will understand that where on the screen that dot should be displayed. Now processor will send that information again to the operating system. Okay, so this is the place where the dot should be displayed, right? Processor will tell that to the operating system. Now again the operating system will convert that into another form that is understandable by your monitor, right? Because at the end of the day it has to be shown on the monitor. Now that signal will be again converted into another form, and then it will be sent to the monitor. Now monitor will then display it on the screen accordingly. So this is how the thing works behind the scene. An operating system will interface between the different requests made by the application level software, and then convert it into appropriate form, and then ask the processor to compute that request, take the result from the processor, and then again operating system will convert it into another form which is understandable by the other hardware which has to work on that data. It might be your printer, it might be your monitor, it might be your speaker. If you're listening to a music, then that hardware will be your end hardware will be your speaker. So then operating system will again convert it into a form that is understandable by the other hardware, and then it will send it to that hardware. So all of these things is done by behind the scene by the operating system. So it is mainly managing all the hardware that are given to you inside the computer. So this is the work of your operating system. Now one question: if operating system is also a software, right? So where is it stored? Is it stored in your hard disk or is it stored in your RAM? Where does it reside? Anyone say that? Comment on that.
It is stored in hard disk, but when we boot the computer, it is loaded into the RAM.
Correct.
First
Correct.
of all,
Correct. So like all other software or all other information or data, whatever you want to say, like everything is stored in hard disk and then it is taken into RAM when you are executing on it or when you are playing it or whatever it is, when you are basically concerned about it and do some work on it, then only it is copied to the RAM. Just like that, operating system is also stored on your hard disk, and then it is copied to the RAM. But the thing is, here you do not select, like let's say you open Microsoft Paint, you click on Paint and then only it will be taken inside the RAM and done, right? I mean then the computation starts. But operating system, you do not click on operating system, right? It is starts from the beginning. You switch on your computer, it starts. So basically this is what happens is, when you switch on your computer, the operating system which resides basically in your hard disk, it will be taken inside your copied inside your RAM, and then only from the RAM your everything will work. So a major part of your RAM will already be filled by operating system when you switch on your computer. So if you have an 8 GB RAM, do not consider that your what, let's say you are playing GTA 6 in your PC, which I think it is released or maybe might be released. If gamers are there, you can correct me. So if you are playing GTA 6, then GTA 6 will be, you do not expect it to be completely using the RAM, right? Because RAM's a lot of space inside the RAM will be already covered up by your operating system when you have started the computer. Fine. Okay.
So, when you say that about the paint file, so if we open the paint, will the complete paint software be converted into RAM, or just the file that we are using?
Correct. So first of all, that file will obviously be taken inside the RAM. Now, since the paint software is running, so it will, I mean, uh, let's say it in this way, there are little more intricate details into it, but 99% of the paint will be taken inside the RAM. Okay.
Okay.
Yeah, 1% it's not required because some functionalities are such that they are not required all the time. So that's why it is unnecessary to take those heavy facilities or heavy, how should I say, heavy utilities which are a part of paint software inside the RAM at first when it is not required. So if it is required, then only it will be copied. But since paint is considerably a light software, so most of it will be all taken inside the RAM. Fine. So if I would have taken an example of, let's say, this kind of games, right? GTA Vice City, or or let's say a heavy game which is running, or let's say heavy software, let's say image editing software or video editing software, which are very heavy softwares. If I would have taken an example of those software instead of Paint, then the answer would be no. The full software will not be taken inside the RAM at every point. That's why the buffering happens. That's why you slow down. If you have a less RAM, it takes time for the computer to process, because all of it is not taken inside the RAM at once, because your RAM is not that much big, right? Because operating system will be taking a lot of space, and then whatever space is left over, there are other some pre-reservations due to some specific things are there. I'm not going into those details, but then only you have the user space. In user space only you can run the softwares which are, your application software. So that's why the full thing is not taken inside the RAM, but for Paint it will be, because Paint is rather a lightweight software, right? Okay,
Okay, thank you.
sure. So now one question again, as I was talking about this thing, right? Operating system, once you start your power button on your computer, slowly the operating system from the hard disk will be taken inside your RAM, and then only RAM will start working. I mean, operating system will reside in your RAM and basically the things will start working. Now, the question comes, okay, if it is in the hard disk and someone is basically copying or loading the operating system from your hard disk inside the RAM when the computer is starting, then who is doing that? I mean, till now we have discussed that computation and all the hardware, everything is managed by operating system. So operating system takes the request from your keyboard or whatever your pen type or whatever you are using, then convert it into a form understandable by the processor, sends it to the processor for computation, takes the result back from processor, converts it into another form, send it to the other hardware. All this stuff is done by management, stuff is done by operating system. So if everything is done by operating system, but when operating system is itself not loaded, then who is operating the hardware at that point? Because then also hardware is getting operated. Your operating system is in your hard disk. It is loaded from hard disk into RAM just like any other software. So if OS is itself not into the game, then who is basically loading the OS from hard disk inside your RAM? Right?
CPU,
Sorry, can you say again? I couldn't hear.
CPU,
City. Sorry, can you write? I'm not able to clearly understand.
CPU.
CPU. CPU is your processor basically. Okay, so this is processor is CPU. Now CPU is again a hardware. So as I said, hardwares cannot do anything by their own, right? I mean, it's just an electronic circuit. You give signal to it, it will work. You take the signal away, it will not work. So any decision making process cannot be done by any hardware, and that is why we need operating system. So unless and until CPU or processor, whatever you call it, both of them are the same thing. Your i3, i5, Intel i3, i5, AMD, Ryzen, all those things are processor. So until and unless you take an operating system, the operating system puts a request to the processor or your CPU, it cannot do anything on its own. No hardware can do anything on its own. All the things will be managed by operating system. Fine. So no, processor cannot handle it because it is a hardware. So it cannot do things on its own. So anyone else? Any ideas? Who
Sir,
brings the tell.
BIOS.
BIOS, great. BIOS. So BIOS, when you start your computer, you see your BIOS menu and boot menu, and you press F2 if you need to make some changes into your BIOS. Quickly press F2 and then go into BIOS. So all those things many of you might have experienced. What is BIOS? So let's say you put the power button on your computer and then you see the name of your computer company or maybe your monitor company, and then only the next thing that happens is for BIOS setup, press F2 or something like that might come, or even not that, just the BIOS will be written, a BIOS, BIOS menu, boot menu. That's it, something like that. And then only your Windows sign will come or Linux sign will come, and then the operating system starts. In that little duration, you have to press F2 to get into the BIOS menu. So I think many of you might have experienced this, and if you have not, then you can just try it. That when you switch on your computer and just the company names comes before the Windows sign is loaded, just when the company or some maybe Intel or whatever, HP, Dell, whatever it comes, just press F2, keep pressing F2, and then you will see some computer, earlier it was F10, F12, all those, mainly F keys, function keys, but I think most prominently F2 is used. So if you press them, you can go to the BIOS menu, and then you see your RAM, your hardware configuration, a lot of technical stuffs will be mentioned, and you can do things over there. Fine. So that is what the idea of BIOS is, right? Okay, correct answer. BIOS actually does, tell, ask.
What exactly is BIOS? Can you please explain?
Sorry, not exactly BIOS.
No, what exactly is BIOS? Can
BIOS
you
is,
explain?
correct. That's where I'm coming. So BIOS's full form is basic input output operation. I mean, I think services or something. Maybe I forgot. I forgot the main full form. I think basic input output was there. I think S was something else. You can check it.
Yes, sir. Basic
System.
input output
Yeah,
of
system. Fine. So the thing about BIOS is as you can understand by the name. So it will configure your hardware and mainly your hardware, right? BIOS, since it says basic input output, what it will do is it will basically check all the hardware in your computer before starting before loading the operating system. because operating system is a manager of hardware. So consider all the hardware in your computer, considering your RAM, considering your monitor, your whatever, everything inside your computer, right? Everything, consider them as an employee in an organization, and operating system is basically a manager. So before actually calling the manager, there is a group, maybe the HR department, they will see all the employees are at their place or not. I mean, I want to see that all the employees are okay, they are ready to do the work, and then I call the manager, okay, now manage them. So this is your HR department's work is done by this basic input-output system, right? BIOS. So they will see that all the, yeah, ask.
Yeah, got it. Thank you, sir.
Yeah. So they will see all the hardware units are working, everything is fine. Then only it will next go to the phase of loading the operating system. Now, okay, great answer. So BIOS actually checks the hardware, the input and output hardware.
Excuse me, sir.
Yeah, go ahead.
So can we assume that BIOS is an inbuilt part of the computer only?
So that is the part I'm coming. Good question. I will come to that. Actually, I'm coming to that. But before, let's summarize once again. So what does BIOS do? It will check all the hardware, and it will see that everything is fine. If there is some hardware technical malfunctions within your computer, then the BIOS will itself stop at that point. It will not start your operating system, right? It will stop at that point, and your computer will not start. So if your BIOS is not working, I mean, let's say even the Windows sign is not coming or Linux sign is not coming on your computer, then it is a good indication that there is some issue with your BIOS. And if there is some issue with your BIOS, that is again a good indication that there is some hardware issue. Okay, there are minor here and there of things, but mostly it is like that. So yeah, so now BIOS will basically check these hardwares and all other workings of the system, and then it will, next thing it will do is part one BIOS. So BIOS part one will be check internals, which is basically your hardware, right? Part two will be your load OS. Fine. Actually, this is not, I mean, technically speaking, BIOS, we call it BIOS, but this part, loading OS, is again done by a separate subsystem of BIOS. We call it something else, but we don't need to go into those technicalities now. Let us assume BIOS only do two parts. First is your check internals, second is your load OS. Okay, but just for your knowledge, there are some fine, I mean, if you just tell someone that BIOS load OS, and if he is a completely computer guy, then he will say, no, you are not telling right. The thing is, BIOS has a separate subunit, and that does the work of loading OS. And if you directly tell some technical guy, he might say that, okay, no, I mean, but for your understanding, it is enough to understand that BIOS does it. Now, coming to the question, okay, so BIOS does this task of checking internals and loading OS. Then where does BIOS reside? As you asked, one of you asked that, can we assume that BIOS is an internal part of the computer? So where does this firmware, I will call it firmware. BIOS is a logical name, right? Depend upon software name. So what basically it is basically a firmware. And another part of BIOS is basically before, actually, that's why I'm saying there are multiple subunits, right? When I say BIOS has multiple subunits which comes beforehand and after, which comes before launching of this so-called BIOS, and some part which comes after BIOS. But for your understanding, consider the whole subunit, whole unit as BIOS, and there are separate subunits, and one subunit triggers before exactly the BIOS subunit starts, and then again some subunit triggers after the BIOS subunit ends. All those things are there, but as of now, just understand fundamentally, crudely, it is the BIOS. Okay, so you might have heard the word bootloader, right? So bootloader is also a part which will come into action. This is also, let's say I put everything under this BIOS umbrella. Okay, but it is not like that. It little bit, I mean, technically speaking, there are some differences within that. Basically, these are different modules, but for your understanding, this is fine. So bootloader is there. That is basically loading your OS. Okay, so bootloader, that subunit basically loads your OS. But anyways, so this is what we call a firmware. Okay, so this is there. I mean, it is called a BIOS is basically a firmware which is already present inside your computer already. Now when I say computer, I want to just answer a question which was asked earlier, and I'm not taking the name directly. Can someone tell me where is it stored inside your computer? If I'm telling BIOS is a part of your computer, where does it remain?
Inside Rome.
Correct. So now to answer the question, that's why I was not directly taking the ROM name. To answer the question which was asked earlier, this is where ROM comes. Okay. So your primary memory and secondary memory, I think one of you asked that what is ROM. So your firmware is loaded inside your ROM. And that's why ROM is called read-only memory. So you are reading the firmware from your ROM. Now, ROM is basically an electronic chip, let's call it a chip, and inside that a firmware is written. Now, the thing is, operating system is written in C language or C++ language, both your Linux and your Windows. But nowadays there are few operating systems which are written in Rust language. But let's say mostly operating system is written in C language or C++ language. Okay, fine. But since C or C++ is a programming language, in order to understand that C++ language, the machine needs another program. Okay, so if you directly put C language or C++ language on your hardware, the hardware will not understand anything, because hardware only understands binary 0 and 1. Now, those of you do not know what binary number system is, 0 and 1, we have one tutorial up maybe in the next week it will come about what are binary number system, what are the importance of this number system and all of that. I will not go into the details of it in this session, but binary is basically a number system, like decimal number system is 1, 2, 3, 4, 2, 0, 1, 2, 3, 4 to 9. Likewise, binary is a number system which only has zeros and 1. And why it is used in electronics? It is used in electronics because 0 means your off state and 1 means your on state. Because electronics can only understand either off or on, at least digital electronics can only understand off or on. That's why we use this number system. So when I say a number like 01100, like something like this, so let's say each of these bit takes 1 second of time. So this will be basically 5 seconds of, this represent 5 seconds of time. So if I give this data to your one of the electronic circuits, so it will understand, okay, maybe from the first second. Okay, and another thing, in this number system, we start counting from your right hand side. So this will be your first digit, this will be your second digit, like that. So maybe in the first second the electronic circuit will be off, in the second the electronic circuit will be off, the third second the electronic circuit will be on because 1 is there, and then fourth second also it will remain on, fifth second again it will turn off. So by using this number, I can communicate with my electronics that whether he has to remain on or off, right? So that's why, because electronics only understand this 0 or 1, that is on or off state. It will not understand what is 9 and what is the difference between 8 and 9. But it will understand this is on and this is off, that's it. So that's why we use binary number system in electronics. Now the point is, basically your C program, basically your operating system, which is written in C or C++, right? C or C++ basically makes your OS. So your C cannot be understandable by your machines, and basically your hardware, right? So you need to have something written in zeros and 1 in order to understand directly, in order for it to be directly understandable by your hardware. Now, if at this point when operating system is not loaded, right, ROM is doing that, my firmware must be in a form which is directly understandable by your hardware, right? Because if I again write it in a way, the firmware software which is there, basically the BIOS software which is there inside your ROM, if it is completely written in one of the languages, let's say Python, C, C++ or whatever, then again the same problem happens, because OS is not there, who will convert it into a form that is understandable by hardware, right? So that's why your firmware is always written in mainly machine code. This is, if we write a code using zeros and 1, that's what we call a machine code. Why? Because it is directly understandable by machine. So we call it as a machine code. Okay. So you have a machine code, and then so whatever firmware is written inside your ROM, it is directly written in the machine code. Now, if it is written in zeros and 1, then you need no one else. You don't need a bootloader, you do not need your OS, you do not need anything. Just take the power button on, put the power button on, and whatever is written in zeros and one will be directly given to your electronics. Electronics will understand that it has to remain on or off, and then it will start working. So the code inside ROM, maximum part of it is written in the form of a machine code, which is basically in zeros and one binary. And this facilitates us to not have any other subunit of a software like OS or something else, which will take the form, which will convert it into form understandable by the machine, because we are already writing it in the form which is directly understandable by the machine. And we are doing it because we do not have an OS at this point. OS will be loaded after this point. So that's why it is ROM. Inside the ROM, the firmware is written in a way, in a machine code kind of manner. And I said that most of the data inside ROM, most of the software inside ROM is written in machine code, not the complete part of it. The some part of it, like the bootloader part, which comes into the later, which basically your hardware checks and internal checks will be done, and then your OS will be loaded. Now, when the OS will be loaded, the second sub part of BIOS, which is bootloader, let's say, right? I told you there are multiple sub parts, but as for our understanding, this is fine. So the bootloader, when the bootloader comes into action, a lot of part of the bootloader is also inside ROM. Everything is inside ROM, right? All things are inside ROM. That's why I said that you only concentrate on the word BIOS. Everything is done by BIOS, and everything of the BIOS is stored inside ROM, right? So your bootloader is not written mostly in the form of your machine code. It is written into a form which is a little bit easier than machine code. You don't have to write in zeros and one, but you cannot also write in any language C++, because still the OS is not there. OS will be only taken, only put into the memory after the bootloader. So bootloader is written in another language. I'm just mentioning it, but no need to keep in mind all these things. This is just for completeness. Assembly language. Okay, this is written in assembly language, which is a little bit better than machine, zeros and one, and much more difficult than your C++ or Python. But why is it so? Because again, it is easier to understandable by machine. May not directly understandable, but it is much easier for your electronics to convert your assembly language into machine language, basically, than to convert a C++ code into machine language. For converting a C++ code into machine language, you need an operating system for sure. But for converting your assembly language into machine language, you do not need a operating system. It can be done by some other things as well. And that's why we do not write all the part in the form of machine code, because machine code is very difficult. You understand only 0 and 1. You have to write a full program in zeros and 1. It is very difficult. So anyways, the main idea is inside the ROM, you may not be keeping in mind all these details. Just keep in mind in this way. I'm just revising all the stuff, and that's it regarding this discussion. So your computer has your memory and your computational unit. Computational unit is basically your processor or CPU, and your memory is primary and secondary memory. Primary memory is very fast, and because processor is a faster device, in order to interact with processor, we need a faster memory so that everything runs in a smooth way, and that's why we have something called RAM. But whatever is there inside your computer, it is basically stored into your hard disk. All your C drive, D drive, E drive, whatever is there, all those things are stored into your hard disk. Whenever you start executing a program, maybe any software, maybe any song, video, whatever, everything is copied from hard disk inside the RAM. If the program is very big, done in a part by part manner, then from RAM it will be given to the processor for computation, and then processor will generate a result and send it, basically generate a result. Now all these things are managed by operating system. Operating system itself reside in the RAM. When you start the computer, it is already loaded inside the RAM, but initially the operating system was inside the hard disk. It is loaded into the RAM by a unit of BIOS, which is basically called bootloader. Okay, and this BIOS and all this which we call the firmware altogether, this is stored inside your ROM. And since initially we do not have any mediating software or manager kind of software, because OS will be loaded later, so that's why whatever is there inside your ROM will be written in a machine code manner, and so that it is directly understandable by the electronics. And then everything, once the electronics are fine and bootloader starts the action, it loads the operating system into your RAM, and then once the operating system starts, it becomes the manager and it manages all the hardware and everything. So this is how things are done. Keep this basic picture in your mind on how a computer works, because now the question is, where does DBMS comes into this picture? I will go to your doubts. Many of you might have many things to ask. I will just go to that part, but before that, I want to mention one thing, that where does DBMS comes into this picture? So database management system is as good as an application software like MS Paint or anything, your Excel or a game that you are playing, whatever. So it is again a application level software. So your what I mean, your database management system, that software, like many of you, I think in the previous session, the instructor showed you guys to download the PG admin environment, and I mean to install it, and all those things are discussed, and even installation manual is also, it will be given, I think. If not given, it will be given in the next week. So when you basically go into the SQL queries and all of that. So all of these things that your PG admin that you are installing, these are basically application level software that will interact with the operating system, and operating system will do the stuff. Okay, so keep this thing in mind. Now, why I discuss this thing, computer internals, the reason is that DBMS is, as I said, it is an application software, that is correct, but we will study DBMS in a very detailed manner, and that details will delve into hardware, into operating system, and at the application level also. So we will also see how the DBMS store data, right? And memory, and when you talk about storing data, it will be stored inside your memory. So when memory comes, that means your hardware comes, and once hardware comes, then only you will understand, okay, so then operating system is also there. Right? We will talk about storage of data, how database management systems store data. It doesn't store data like normal saving. It has very complicated internals of how data is stored. And I think it comes in week 8 or week 10. We will discuss that how the data is stored inside a database management system. Right? So those things will need you to have a fundamental understanding of this background working of computer. So it is important. It is very important for you guys to understand. Fine. So now I will take questions. Ask everyone who want to ask something regarding this topic, okay? And then again we will go to week 1 slides after this.
Sir, can we write firmware in assembly language?
That's what I said, right? That since I'm fundamentally describing the overview, a kind of overview of this stuff, I'm not going into details, but firmware is written. All this thing is firmware, right? Your bootloader, your BIOS, everything, all of this is, we call these things firmware. Now, a part of it is written in the machine code, and that part is basically the first pieces of code that will be executed, right? Because it is in machine code, it will be directly understandable by the hardware. But the whole thing is not written. So whatever content is there inside inside ROM, not the whole ROM is filled up with zeros and one. I mean, not the whole thing is filled up with machine code, right? A lot of part of it is also written in some other code, which is basically your assembly language. So if you ask me whether firmware can be completely written in assembly language, firmware is an umbrella term. If you really want to answer this question, you have to go into the depth that, okay, this subunit is triggering at first. So this has to be written in machine code. And then let's say once this part comes into action, then I will have the assembler at my arsenal. So once I have the assembler, the next subunit can be written in assembly language because assembler will convert it into machine code. So these details will come into action. So I'm not going into all this part because those are not required for the course. What is required is you have a fundamental idea of how, I mean, this basically an overview of how things work, right?
Okay.
Yeah. But if you are interested in it, you can just, I think there is OS course. So operating system course is there as an elective later on. It's not, and at this level it is not there. I think as an elective it is there, maybe a little bit later. So in OS you will understand, you will learn all of this in detail. You will see the code, and if you take OS, I think OS is optional. It's not elective, I think. Sorry, it's not compulsory. It is elective, I think. In when you go down further your degree, OS will be there. When you study OS course, if you take OS course and study it, then you will understand all these details. Okay,
Okay, sir.
sure. Anyone else?
Sir, I have another question, sir.
Yeah, go ahead.
Sir, if a computer system has BIOS, like it is a software or interface that interact our OS to the computer, sir. But what if a memory doesn't have any kind of software to interact with the hardware? Then how does we approach towards the installation of that interface or installation of BIOS software into the hardware, sir?
BIOS, that's what I told, right? BIOS is written in most of the first part of BIOS is written in machine code, which is zeros and one. Now, zeros and one, that's what I told, that it is directly understandable by your electronics. So you don't have any don't need any mediating software to make it into a form that is understandable by your electronics. So if I'm
Sir,
written, go ahead, go ahead.
but there may be some kind of interface so that we could transfer the BIOS software into the memories.
No. BIOS is inside the ROM. Okay, so see how things work is BIOS is already there inside your read-only memory, your ROM. BIOS is not taken inside your RAM, and I mean just like everything is from your hard disk is taken inside your RAM, and then it starts working. BIOS, which is basically your ROM doesn't work like that. ROM doesn't have to be copied from ROM. You don't copy it into RAM. Those things are RAM and hard disks are completely separate. They work hand in hand. ROM is completely separate. ROM is not getting copied into RAM and anything, nothing like that. ROM itself has a software written inside it. Since at this point no mediating unit like operating system or some other interfacing software is not there, that's why the content inside ROM is written in a way which will be directly understandable by electronics. So that is machine code, your zeros and one. Right?
It means, sir, it is rebuilt, pre-built in the ROM itself.
Pre-built, correct. And by the way, your ROM will always be powered. Okay, so if you open your motherboard, you will see a circular battery is there. A tablet-like battery is there on your motherboard. So that battery is given to give power to your some units. A little bit of chipset, some chipsets units are there, which are in modern motherboards. They give power to those units as well, and it also gives power to a unit of ROM and a unit of clock, which basically is always given power, so that basically whenever you switch on your computer, the power given to ROM through that battery basically opens the wire lines of ROM, and then the data, I mean this hardware, this machine code is directly comes to the bus. Bus means the wires, and it goes to the processor, I mean goes to the hard disk to load the operating system. Okay, so these are much intricate details. We don't need to go into that. Just fundamentally understand this, that you do not have to copy the contents of ROM into RAM. We don't do anything like that. ROM is an independent unit of memory, and its primary function is to start the OS. Okay, and check for hardware correctness. So for doing that,
Sir, if there is a general kind of memory like SD card, sir, we have like file system in it to interact with us and to send any kind of files into it, sir. If we didn't have file system in a new build memory, sir, then what is the kind of interface over there so that the file system could be installed into that?
Operating system is there, na? So when you are talking about USB and your SD card and all this stuff, before you put an USB in your machine, you have already operating system running on your computer. So all those things are taken care of by device driver unit of operating system.
Okay, sir. I think, sir, some part of the BIOS software would be used so that the electronic system of that memory could be understood easily.
You don't need that, because OS will take care of that. BIOS is only coming into action when OS is not there. To load the OS, you need something. Once OS comes into action, he will take care of everything. But to load the OS, you need someone to do that, right? And for that, we use ROM. And since no one can convert into any form understandable by hardware, since OS is not there, and basically we are primarily talking about loading OS. So that's why it is written in machine code. This is the fundamental idea. Once you have OS, it will take care of all other things. Okay.
Okay, sir. Thank you, sir.
Anyone else? Any doubt regarding this discussion?
Sir, what is the difference between SSD and HDD? Like how both are like SSD is more better than HDD?
Okay, so this particular discussion will come into, I think, storage devices week 6 or week 7, I forgot, whatever. So, well, where we will compare different kinds of storage devices, how memory is stored, consider the internals of storage devices. Okay, so I will prefer to discuss this over there. But basically, SSD is also I'm just briefly telling SSD is a much faster than hard disk and slower than RAM. So it comes somewhere in between, right? It comes somewhere in between over here in terms of speed and price, capacity, all those things. So it is faster than hard disk, slower than RAM, costlier than hard disks, less costlier than RAM per unit of storage. I am talking about per unit of storage of SSD is much costlier than hard disk and less costlier than RAM. Now, if you ask that how SSD is different, this is from a naive perspective that it is costlier, it is faster than hard disk, all those things. You have already heard about it since you are asking that, okay, you might have also put an SSD in your laptop or computer. But if you want to know the internals, that how it is actually different from hard disk, then we have to discuss a lot of other stuffs, and I would prefer to discuss it in that week. Okay. Fundamentally speaking, hard disk just basically, since you asked, I will not go into the details. Hard disk works on magnetic storage. Okay, so can I ask, are you from science background?
Yes, sir.
Okay, so in class 12, have you learned about your magnetic dipole moment, hysteresis loop, retentivity, all those things?
Yes, sir.
Okay, so hard disk basically works. It has a magnetic film over it, and you put another magnetic field, electromagnetic field, using a read-write head on the hard disk, and those basically magnetic moment, it will generate a magnetic moment, and it will create a magnetic up moment or magnetic down moment. For others, you don't have to understand this, because we will discuss these things in later weeks, and not also that we will not discuss these things in that much detail way, but since someone asked, I am answering. So it will create a magnetic dipole up or the up or down moment, which basically signifies your 0 bit or 1 bit. Okay, so that's how your data is stored inside a hard disk. You use magnetism to store it, but inside your SSD it is not done in that way. That's why we call it solid state drive, SSD, sorry, not SSD, SSD. It is called a solid state drive, and inside your SSD things are stored in a manner which is completely different, and it is not related to magnetism. It is related to semiconductor physics, which basically uses a VNAND technology, vertical NAND gate NAND technology, and basically it is done in a it is a semiconductor that is basically your field effect transistor, that is FET, right? If you also have learned a little bit of transistors in your class 12, so your field effect transistors are used, multiple MOSFET, right? You might have learned MOSFET and all those things. So a special kind of field effect transistor is used, which can store electrons at separate 8 levels inside your SSD, and that's why every transistor present inside SSD can store basically 8 bit of information. That's why it is much faster, and it can operate in a better way. So I just kind of went on a random full speed explanation. This is because you mentioned, and I don't want to go into the details at this point, but still just this is the fundamental of it. So HDD works on magnetism, SSD works on semiconductor physics, and semiconductor physics is much faster because you are directly dealing with electrons, but here you are doing magnetic dipole moment, and which is kind of a mechanical concept, and that's why it is much slower. Okay.
Sir, but the data is stored into 0 and 1 only in both the cases.
Data, so obviously, because you do not have anything else where the electronics will understand, right? 0 and 1 ke alawa, you do not have anything else where electronics don't know about it. Electronics only understand either on or off. So whatever kind of technology you are using, it has to be at the end of the day in zeros and one. But if it is a mechanical kind of technology like magnetism, then I mean it will take some time to do the reading and writing. And if it is electrons, directly electrons, then electron speed it's like an electromagnetic wave, so it will be very fast. It will work faster, right? Yeah.
Okay, sir. Thank you, sir.
Right. So yeah, for those, again I'm stating these are not requiring this much detail. It's just personal level I answered a query. Anyone else?
Sir,
Go ahead. Yeah.
so when you say that ROM is used to operate, like to upload the operating system into processor, so it's just temporary, like
Yeah, not
memory,
processor.
or
Inside RAM. Processor is not doing anything. Everything is copied inside RAM, and RAM
okay,
serves the request to the processor. Yeah. So OS is loaded into the RAM. Yeah. Go ahead.
into the RAM. Okay, sorry. So is it a primary memory? Like where is actually ROM? Like is it temporary
Correct.
memory or?
Correct. Correct. So ROM, I think I also may be wrong in this, but maybe ROM is considered inside secondary memory only. You guys can check on online whether in which category it falls. This is the
Okay.
functioning behind it. Okay, but I might be wrong. But since it is storing the data always, I think it should be called secondary memory. But I'm not sure about it. I might be wrong. Just check the under which
Okay.
category it falls.
Okay, but then the data gets erased, like just like the primary memory, right?
No, no, no. ROM data retains, right? That's what I said. Because if the data gets
Okay.
erased, then who will load this machine code again inside ROM? No one else is there, right?
Okay. Okay. So data is retained.
Yeah. And that's what I said, that you have a battery inside your computer, a tablet battery, which gives power to the ROM always, even when you switch off your computer, even if you put off your switch, power switch, right? So there will be one battery which will constantly powering ROM so that it can work when you basically start the computer.
So when the we start the device and the OS is uploaded into the RAM, it's always stored in the ROM.
Not the OS. OS is stored in hardware. So let's say like this. OS is there inside hardware. I mean, not hardware. Sorry, I'm sorry. Hard disk. OS is stored inside hard disk. OS will be loaded inside RAM. Loaded inside RAM. Now, who
And
will do this loading? Loading will be done by the code written inside ROM, which is firmware. Done by,
okay.
right? Done by.
Okay, so ROM does not have the OS.
No. OS is a huge file. ROM is, I think, it is 64 KB or something like that. ROM will be around that. Your OS will be around, maybe older OS may be around 6-7 GB, around something like that. I mean, extracted version. So overall version will be much larger, but extracted version may be around 6 GB, 5 GB, something like that. Okay, so it is very large. OS is very large. So OS, that's why, will reside inside hardware. Inside hard disk. But since OS, everything like every other software, OS will also be copied from hard disk inside RAM, like everything else, right? I talked about whatever you are doing on your computer, everything will be there inside your hard disk, because RAM will forget everything once the power is switched off. So that's why when you switch on the power, hard disk will not forget. Hard disk will give everything, all the whatever is needed, it will give that into the RAM. And just like that, OS is also there inside hard disk, and it will be loaded inside the RAM, right? And this loading will be done by your firmware, which is there inside your ROM. And ROM will always be given powered by a battery, and that's why ROM will always retain the machine code or the firmware or your BIOS, whatever you want to call it, or your bootloader, all those things, whatever you want to call it, it will be there inside ROM always. Okay, it will retain, and that's why I said ROM is secondary memory, because it retains all the information. But I'm not sure. Just check it. Okay.
Okay. Thank you.
Go ahead. Fine. I think that should be okay for this discussion. Now let me go to the slides. So this is kind of your end of week 1. So I would, rather than going through all the things one by one, let me ask you guys have studied it, I hope. Any specific part to discuss first, because I want to address that first, and then maybe I will go slide by slide. Any specific part which you have read and not understood, or maybe have some queries on that, some doubts, something like that? By the way, so when is this graded assignment submission deadline?
It's on 25.
25th. Okay, so then no one has read anything. That is understandable. Okay. Yeah, so I will be asking this one last time. If someone has doubt in very specific part, you can go ahead and ask it. Otherwise, I will maybe go one by one. Yeah,
Can you explain DDL and DML and those things?
DDL, DML, DDL, DML. Okay, so I think it is here. Anyways, I will just go over. So as we know that inside your database system, you will have a schema and instance. Now, what is schema? So let's say you have to draw a table. I mean, forget about DBMS and all those stuff. Just let's say I ask you to jot down information about all the students in DBMS course, right? So how will you do it? You put it into a table, and sorry for the sound. And inside the table, how will you basically create the table? You will put, let's say, the name. Okay, maybe the roll number before that, roll number, roll ID, name, and maybe whatever. I mean, whatever you guys do at current education level. Okay. Maybe your if you have any job experience, that job experience. Okay, maybe your phone number, right? So like this, you will add all the fields, whatever is there, and then these will be your attributes. These fields, we call them attributes. We will see these things later in the next week. All these fields, right? These are the fields which define the content of the column under them. So whatever will be there in this part is defined by the name of that column, right? So basically, we call these. This name, role ID, current education level, job experience, phone number, all these things we call them attributes. Just terminology, nothing else. The idea is the normal idea. So these are the attributes, and whatever will be inside this table, right? The rows of information, roll number 1, roll number 2, ... whatever, all this information, all of this information part, this is what we call instance. Okay, this is completely considering all of the information part. I mean, the name of the students and all those things, the whole information rows of information, we call them instance. And all these attributes, each of these are called attributes. So phone number is an attribute, job experience is an attribute. So all of these considered together is called attributes considered together. Is called schema. So this is the scheme of the table, that how the table should look like, what are the data present inside the table. So that is what schema tells. So any schema, the word schema means that, right? What is the scheme of storing, or let's say what is the scheme of doing this work, how you are planning to do this. So that's why we call it the schema of the table. And all these rows of information, the personal details, are basically called the instance of the table. Now, when you go into SQL, right, we know that in maybe week 2 and week 3, we will learn about what SQL is. SQL is basically a language to interact with your database. So you write questions in the form of SQL code to your database engine, and your database engine will understand that SQL code, and it will return the result, which will be basically the preferred rows that your code asks for, right? So this is how the thing works. So the SQL code that you will learn, it is primarily considered into different kinds of SQL code, right? So which serves different purpose. So the part of SQL code which serves the purpose of defining the schema, or operating on the schema, or manipulating the schema. So let's say I want to add another field, not phone number, let's say address. Let's say your permanent home address. So I need to write an SQL code. Already address was not there. Let's say this phone was the last column inside the table. Now someone told me that also we need to add the address of the student inside the table. From my senior position, someone told me. Now I need to add the address field inside the table for the students, right? So this address is what? It is a part of the schema. Now I am adding an attribute, which attribute is basically part of the schema. So since I have to make a change in the schema part, so that's why the code of SQL that I will write, the SQL code that I will write to add this address column inside the pre-existing table, right? So that code will be a DDL code, data definition language. So any SQL code which deals with the schema part of your table, that is called data definition language SQL. I mean, that is segregated into the data definition language part, all the codes. Like, so when you learn DBMS, when you learn SQL, you will see alter will be there, drop will be there, right? Create will be there. All these are basically your DDL codes. DDL, not codes, basically, yeah, DDL commands. So these will create the table. So create is basically creating the table. This whole table will be created. Alter is, as I told, that if I want to add an address, so I need to alter the table. So I will use alter command. Drop is basically it will delete the table. So when I'm doing things with the table as a whole, which is basically the schema, so those operations are called DDL operations. And when I am doing manipulations or additions or subtraction on the instance of the data, right? That is the personal level information. So let's say I ask you that, tell me the details of a student whose name is, let's say, Albert Einstein. So I have a student named Albert Einstein, and I ask the details that tell me the current job experience of Albert Einstein. You put an SQL command inside your DBMS, and DBMS will read that SQL command, that okay, and it will see in its database that okay, Albert Einstein is which roll number? Okay, so here it is Albert Einstein. So what is the job experience of Albert Einstein? This is the job experience. This is what my user is asking me. So I will return this to my user, right? I will send it to my user. So this is how DBMS will work. So anything which is related to the manipulation, insertion, deletion, changes of the instance part of the data, that is these rows of information, not the schema part of the, that is not the table, not the schema, but the instance part of the database or the table. Any operation that works with the instance part are called DML, data manipulation language operations, right? So like insert, now insert will insert a row inside your table. Delete will delete a row from your table, like this. Fine. So this is DDL and DML. There are a few more details into it, but we will understand that when we go into the SQL.
Sir, when you say schema, I heard sir mentioning in the lecture about this good schema and bad schema. Can you please explain that?
So good schema, see, since this is week 1, we are doing a kind of summary that what we will learn, an overview of the things that we will understand in this as a part of this course. So like, that's why it was mentioned over there in the first week itself that good schema, there is a notion of good schema, there is a notion of bad schema, but basically the whole course is about this good schema, bad schema. So I will not discuss this in detail now, but just have an idea that you have an idea of good schema and bad schema, and we will understand that how when we call something good, when we call something bad in the further weeks to come. Okay.
Sir, can you explain relational model and all the things?
Okay, so relational model is basically in your next week only, you will understand in detail. Week 2, I think the lectures are already released, so you can watch that. But basically in the next live session also it will be dealt in detail manner, because relational model is the basically in the next week. But relational model, fundamentally speaking, what is it in terms of DBMS is, but by the way, what is relations? Can you tell me that? What is a relation? And not relation means mathematically I'm speaking. What is a relation? Can you remember something? Anything that you can remember?
Structured data.
Sorry, what?
Structured data.
Constructed data.
Anything that relates with something like the variables and constants, like operators. A
Okay,
plus
fine.
B
So,
equals to C, all the things is a relation.
Relation with parents or someone else.
Okay, fine. So
More
let me
about
ask. Let me ask this. You guys have done your maths one, right?
yes, sir, done.
In maths one, you have learnt about relations and function.
Yes, sir.
Yes,
Yes,
sir. In
Yes.
we do.
So tell me from that perspective, what is the relation?
So relation is when elements of two sets belong to each other in a manner.
Maybe correct. So the formal definition of a relation is it is a subset of Cartesian product of two sets, right? Remembering that this was the definition in your book or maybe in
Yes,
your.
sir. Yes.
I will.
So what is the Cartesian product of two sets? Let's do some revision of maths before going into. See, computer science is completely about maths. If you forget maths, you will not understand CS in detailed manner. If you just want to do some, I mean, the fundamental kind of jobs in CS, I'm just going on a light note over here, other kind of discussion. If you want to do some normal kind of job, then it is fine. You can learn a little bit of coding here and there. It will take 1 week or 10 days for you to understand, and you can make a website. That is fine. But all those things are managed by ChatGPT and these LLMs that have come. Okay, so if you really want to put a change in your career, you have to understand mathematics in a detailed manner. So there is no such thing as, okay, understand a little bit of coding, thoda CSS, HTML seekh lenge, and that's it. Those things are gone. I mean, LLMs are coming, and you don't have those menial kind of jobs there. They will not be there for long. It's already not there. There is a job crunch that has gotten created over here. It's dangerous. So basically, you have to understand the fundamentals in a better way to actually put some impact and in your career. That's what I strongly believe nowadays in CS. So that's why do not forget your mathematics. Do not forget your. If you are motivated by some YouTube videos, many of the people tell that you don't have to understand. We will just do these things and you can do good job. ऐसा नहीं होता. At least not now. It was there for some time. Now the scenario has changed, and in the next 5-10 years, it will again change in a drastic manner. So please do not ignore your maths. Okay, you cannot learn coding without your maths. Okay, yeah, I may be sounding contrary to many influencers and many people in the community, but it is the way it is, right? So if you really want to do good work in this domain, if you do something else in your other domain, that is fine. But in this domain, you have to understand mathematics. Do not forget mathematics. Now coming to
Sir,
yeah,
excuse me, sir. Sir,
yeah.
where will get this recording? Like, I have joined it late, so.
I will upload it. I am recording the session. I will upload it on YouTube later. Fine.
Okay, sir.
Actually, I was not aware of the part that it will be streamed. I think some of the students told me yesterday only it was told to them that it will be streamed. So now I am recording it. I will upload it later. No worries.
Okay, sir. Thank you.
Fine. So what is the relation? Coming back to the question, when you have two sets, let's say set A, set B. I hope sets you all remember, right? What is a set? It is a collection of data items which has some specific pattern or a rule that they are following, right? So A and B, let's say two sets are there, and I do a Cartesian product of A cross B, which is basically, so let's say if A had A comma B comma C, and let's say B had the contents 1 comma 2 comma 3, right? So I'm Cartesian product means, what is a Cartesian product?
It's a ordered list
Correct.
of both the elements.
Correct. So it is a collection of ordered pair of
elements.
Of the elements. So B2, E3, right? I'm not writing the C part, you understand. So this is your Cartesian product. Now a subset of this, what is the relation? A relation is subset of A cross B. So that means the relation is basically, let's say R1 is, let's say I take the ordered pair A1, let's say I take the ordered pair B2 and C3. Okay, and this is basically your relation that I'm talking about, and how can I name this relation? So if I want to tell that, how do you define this? Okay, so this is a collection of ordered pair, that is fine. But what is this? Sorry, not a collection. It is a subset of the Cartesian product A cross B. Then it is called a relation. Fine, it is R1. That means basically it is also a smaller collection of ordered pairs. That is also fine. But how, when I am calling it a relation, why am I calling it a relation? So there must be some idea attached to the meaning of the word relation, right? So the relation over here is, let's say, when I say the first element of each ordered pair within R1 relation, and the second element of each ordered pair within the R1 relation signifies the ith alphabet in the English alphabet, right? So if I say that I have an ordered pair of the form x comma I, so x is ith alphabet of alphabet system. So this is the definition of my R1 relation. So not equal to, this should be written in this column kind of. So this is your definition of your R1 relation, and R1 relation looks something like this. So we call it a relation when it has a meaning attached to it, and ultimately what it is, according to that meaning, we will take some ordered pair which satisfies that meaning, and that's why we call it as a subset of the Cartesian product. Fine. So this is a basic maths recap. Now, if you have this idea cleared, then your week 2 and week 3 fundamental understanding will be okay. Now, why are we coming into database management system and telling that it is related with your relation, and why am I calling it a relational model? So the tables and the information that we just saw, like over here, this table that we kind of discussed. So this table will be called a relation. And so then can one tell me that what will be corresponding to the ordered pairs? So,
instances.
Correct, exactly. So the instances or the personal data or the rows of information that we have over here, that we will have over here, those will be corresponding to your ordered pairs. This will be analogous to your ordered pairs. That is the data present inside the relation, and the whole table in its entirety, right? This whole table in its entirety, so this whole table in its entirety will correspond to something that we call basically your relation. So the table, which is basically your table. So the table is the relation, and the data present inside it is basically the ordered pairs. Now, why are we going into this kind of weird analogy between mathematics and DBMS over here? Because the operations that we will do on these tables, that will be very much related to the mathematical operations that we do on these relations and Cartesian product and all those things. Like you have this Cartesian product A cross B, right? A and B are two data sets, and you do a Cartesian product A cross B, which basically means every element of A will be connected with every element of B in ordered pair. So this is basically your join statement, joins SQL code, or not code, command. So when you learn SQL, you will learn a command called join. It is an SQL command. So this join is nothing but your Cartesian product. Okay, so I'm just giving one example now. Once your week 2 sessions comes, you will understand this. So all the operations like we do, let's say we do set difference operation A minus B. We do set interaction is interference I'm talking about intersection operation A intersection B, union operation A union B. All these operations that we do, right, on two sets, onto relations. All these a relation is basically a set. So basically A and B are two relations, you can call that also. So all these operations that we do on a relation, all these things are actually directly will be done on two tables as well. So like here we are talking about A and B are two relations, and we are doing the subtraction from A relation minus B relation. Just like that, we will do subtraction between two tables. Only now we will call these two tables. A and B are two tables. That's why relations are called analogous to tables, and tuples are analogous to ordered pairs. So A minus B, A intersection B, A union B, all these things will be your SQL code or SQL command. Whenever I'm saying code, it is not code. I mean, technically speaking, SQL is not a coding language, it is a commanding language. So that's why if I say code, consider it as command. So all of these things will be SQL command. So at this point, completely going into the details of relational model will not be okay because it is a part of week 2. But the idea I wanted to describe over here that whatever is there in relations, in your mathematics relations and Cartesian product set, all these concepts, all those things will be directly translated into your SQL operations. And you will see the relation over there that, sorry, not relation, basically you will see the analogy over there that if I treat a table as a relation and the ordered pairs as an instance, then we will be able to see these things very clearly and do these things very in an analogous fashion, right? So you guys did your Venn diagrams, right? Like your this circular diagrams, Venn diagram and all those things. You will see that here also you will just, there it was called a relation or a set. Here you will call A and B as two tables. So these represent the instances inside table B. These represent the instances inside table A, and then you do an intersection operation by SQL command, and this is basically represents your intersection area. So whatever we did in relational logic, relational algebra, here also we will do that on tables, and that's why it is considered a relational model. Okay, so this is the fundamental part of it. In the next week, we will see the mathematical as well as the practical coding details of what is relational model and why we call it so. Is it okay? Is it the idea? Is it at least have an understandable overview?
Yes, sir.
Okay.
Sir, what is the transition management component?
Transaction management component. Okay, so transaction is something we will learn again much later in the weeks. I think week 5 or week 6 now. So transaction. What is a transaction is, I think this is a little bit week 1 part is here. So I will discuss it briefly.
And also concurrency control manager.
Okay. So you see that I think in this comparison, when sir has taught compared between SQL and a flat file system written in Python. Where is the full code? So here what happens is you see that you have a Python code and an SQL code. This SQL code is doing what? It is basically doing credit and debit from two accounts, crediting from one account, debiting, crediting into one account, debiting from another account. And it is putting that information that there has been a credit and a debit from so and so accounts into a ledger file. So if you see the lecture, this has been discussed. So this is how this is what is happening over here. Now again, let's say something happens in the middle after you do the debit from one account, but before doing the credit, something else happens. Some problem happens, and this has been experienced by all of us. You buy something online, and maybe there is some issue coming with the internet, or something happens, and the payment is not successful. And if you have bought IRCTC ticket, then obviously you have faced it, because every time you take IRCTC ticket, at least I have faced it most of the times. So if you do buy a ticket, your amount is getting deducted from your account, and a message comes, your transaction has failed. But no need to worry if your ticket is not booked, and that's why you do the rebooking, and the amount will be returned to you after some time. So this has been observed by us in our daily life. Many of us has seen that, and in different instances. Now you will actually understand how this happens, and you will actually do code on that. Okay, so basically how these things actually work, that your incomplete transaction gets logged down. I mean, logged down means logged, L-O-G-G-E-D, logged. I mean, the record is maintained for any incomplete transaction. What is a transaction? I will come to you asked the question, what is a transaction? I'm coming to the part, but the idea is any incomplete payment is, let's say, it is mentioned that, okay, this payment has become incomplete. I have to, the system has to do some work on that and return the money to the owner of that, to the account holder. And basically undo whatever things were done till now. So then you get the money after some days. and your ticket doesn't get booked up, right? But let's say when you click on the book, basically before the paying part, maybe the ticket is not booked, but that booking part, that booking window, actually the system has proceeded quite a lot towards booking it, right? So many jobs are already done towards booking that particular seat for you. But at the end point, your money was not properly deposited, and that's why the operations failed. But before the operations just failed, a lot of work was already being done by the system towards booking the ticket. So not only they have to return your money back, they also have to undo all those things that they have done towards booking the ticket, so that the next person who is booking sees the latest updated seat count, seat availability. So all those things which are done till now has to be undone. Just like in this example on the slide, here credit and debit is happening, but let's say at some point the debit happens, but after the debit happens, that's why here it is written critical point. That's why here it is written this critical point, right? So if the debit happens and then some problem arises in between, then the credit will not happen, right? So something like that, that is a trouble. But that kind of trouble will never happen in SQL. That is basically in DBMS. That's why, in fact, that is why you get your money back. So now coming to answer your question, what is a transaction? A transaction is any such operation on the database which deals with update in the data present in the database, such that it will be done in an atomic fashion. Now, when I say it will be done in an atomic fashion, means what? That means if the complete transaction is executed, then it is fine, then no problem. But I mean, if the complete block of code is executed, then it is fine. If the complete operation is done, then it is fine. But if there is some issue coming in between, then like normal Python or C or C++ or normal code, it will not just launch an exception and stop over there. It will undo all the things that it has done earlier. And this is where I gave you the idea that a lot of work was already done towards booking the ticket. If you do not undo that, then basically that seat will neither be booked by you, nor that seat will be booked by any other person who will try to book the ticket after you, right? So since that ticket was already kind of in the medium state of getting booked and not getting booked, that's why if the system does not undo everything that was done till now, then that seat will not be reflected further in someone else's computer when he is or she is trying to book the ticket. So those undo has to be done. Not only returning your money is not the only thing that is happening. That undo part also has to be done. So if I am doing a debit and in the middle something happens, then normal programming language code will not do anything implicitly. If you write code for that also, then it is fine. But normally they wouldn't do. But SQL or basically any DBMS system, right? They will do this thing, that they will see if there is an issue that arises in between, the whole operation is not done and the part of the operation is done, then the things will be undone, whatever was done till now, and then again we will go to the initially achieved consistent state. So any such, now answering your question, any such set of code or let's say set of instruction is called a transaction. So a transaction is basically a set of instruction which is executed on a DBMS, which deals with changing the data inside the DBMS such that if the whole of the operation is not completed, then it will be reverted back and all the, no partial part of the operation will be done. So I am telling it in a more, let's say, in a more detailed manner, but how you actually state is, a transaction is a set of instruction which is executed in an atomic fashion. Now, atomic fashion means what? You will be completely, either you will be completely executing the operation, or you will, if something happens in between, then you will revert back and not, undo the execution that you have done until now, so that it creates an effect that you have not executed anything within that, within that operation. So either you do it completely or you don't do even a single line of it. So any such unit of code is called a transaction in terms of DBMS. And that's why when you take your money from your ATM, it's called a transaction. If you do anything related to money online, it is called a transaction, because that is done in this manner. If something happens in between, it will be reverted back. All the work will be reverted back. It's like the partial work will also not be considered. Fine. Is it understandable? Is it okay? Yeah.
Yes, sir.
Sir, I have a doubt. Like, what is the difference between PostgreSQL and MySQL, and why we are not studying like other databases?
Great
And
question.
I am confused between these terms. Like SQL is a language, then what is PostgreSQL and MySQL? Could you please explain?
Correct. Okay. So good question. So SQL is a language. SQL is a language. PostgreSQL, SQLite, MySQL, right? There may be many other vendors as well. These are the famous ones. All these things are vendor, are DBMS. All these things are basically softwares or vendors, whatever you want to call it. But SQL is a language. So SQL is common in all these, right? You see, all of them uses SQL. So SQL is a specification. So it is not something which is proprietary to, let's say, Postgres or SQLite or no, nothing like that. SQL is a specification, and so it is a specification. Let's say you have switchboards in your house. Now the government of India has already standardized that, okay, we have 5 ampere plugs and 15 ampere plugs at our home, right? And I mean, mostly no, for residential purposes, and 5 ampere or 15 amperes will be there, and the voltage will be 220 volt, and frequency will be, what is the frequency of current, AC current in India? Someone tell.
50 to 60 hertz.
Correct. So and this will be the frequency of our, I mean, of our alternating current. So this is a specification, right? This is a recommendation, not only recommendation, this is specification. So this is how it should be. Now on the basis of this specification, Havels is creating plugs, Anchor is creating plugs, Orpat is creating plugs, some XXX companies might also be creating plugs on your switchboard, is right, switches and all those things. So specification is something which is standardized, and a product is something which works on that specification and basically does business. So this is how things are. SQL is a specification. It is not something, I mean, it's not a proprietary language to any of the vendors. It's a specification which is based upon relational algebra. Okay, so it is a specification which is based upon relational algebra, and all these DBMS systems, they use the SQL language which is based upon this specification, and they generally provide you with the DBMS system. Fine. So this is the idea of what is difference, why SQL is a language and why these are using SQL and all these things. But now coming to your first part of the question, which is why are we studying PostgreSQL and what is the difference between this PostgreSQL, SQLite, and why MySQL, all these things are there. Fine. So as as a person who will be working in this domain, you guys need to know which tools to use at what point. So this is a very important part of the, part of your course also. So the thing is, SQLite, the name says, this is very lightweight. MySQL and PostgreSQL are much bigger in size, much heavyweight softwares. Okay, and MySQL and PostgreSQL, among MySQL and PostgreSQL is furthermore heavyweight software. So SQLite is lightest. It is your lightest. It is your lightest software. Lightest means it is small in size, it is faster, something like that. Okay, and MySQL is after that moderately heavy. PostgreSQL is the heaviest of all of them. Now, obviously, why it is heaviest, that means it has a lot of internal code in this application, right? And that's why it does things in a much better way than the other two. So that's why we are learning PostgreSQL, just answering from a naive perspective. But now coming into the details of it, I will come into SQLite a little later. Let us first consider MySQL and PostgreSQL. So what is a DBMS system? What is the architecture of a DBMS system? So you see the DBMS system, I am saying DBMS system, S is already system, so please, sorry for that. So DBMS is basically, most of the DBMS that you will work upon, they are mostly client-server architecture. Client-server architecture model. Now, what is this client-server architecture? Although you guys will learn this client-server things in AppDev course in a much detailed and proper way, but assuming that many of you might not have done AppDev as of now, what is a client and server? Client is basically a system which will serve your, that's why it is, sorry, not client, a server is basically a system which will serve the request of a client. So you have a client, right, and you have a server over here, right, and then a client is asking something to the server. Server has information regarding that, and on the basis of that information, server is answering to the client. So this is fundamentally the idea of a client and server architecture. Now, when I'm talking about DBMS, how it is related to client and server? Now, most of you will understand the client and server terminology from there is one server of Google, and there is these internet has different servers, and we write some request that okay, something related to some Google search, and then this will go to the particular server, and then the result will come to our computer. So, but that means that it is related to internet, right? But when I'm doing DBMS, there is no point of internet or anything like that. So where does this idea of client and server comes into the action? So the thing is, mostly in our real day-to-day life, we understand the client-server example and we see it on internet only. But reality is, server is any system which replies to the request done by another system, which is basically your client. So the one who is doing the request is a client. The one who is answering your request is a server. So a client-server system can also be made within your computer as itself. How? One software, let's say technically speaking, it should be called a process. But then, what is a process? Many of you might have doubt. So as of now, consider that software. One software is asking something to another software, and the other software, the one who has been asked about that thing, he has some information and he has some power. He is giving reply to the asking software that this is the answer to what you have been asking me. So if you have two softwares side by side within your computer, right? One is asking something, another is replying to that. Then also it is a client-server model. Okay, understood. Maybe you guys don't have a practical idea of it, but when you learn your system commands course, then most probably you will do some codings. Then you have to create an application, a process, particularly speaking, a process which will work as a client and ask another process which is working as a server within your computer only, and it will answer, the server will answer some things and the client will ask something like this, right? But the idea of client server can be anything which is serving and asking some request. Now, most of the DBMS that we will learn, that we will see in our real world, they are working in the client server model. So the DBMS engine or the database engine, along with the data. Now, database engine is the engine, right? It works on the data, but you need the data also to work on it, right? So the data along with the database engine together constitutes the server. So this basically is your server. And the front end, or what we also call the back end. Okay. And the front end will be basically your, let's say, your interface or IDE or interface for SQL. So the PG admin, let's say in this case, or maybe if you write SQL on your command line, so at that point of time, the process corresponding to that command line. So basically that, consider that command line on your window, which you are seeing. So that is basically in this case your client. Okay, and what we mostly call it the front end. So your client is asking through SQL. SQL, what is the full form? It is structured query language. Query language. So this is something, a language which is used for querying something. And it is a structured manner we do. That's why we call it structured. So querying, you are doing a query. Now, who will you query? SQL means structured query language. Who will you query? You will query the server. Now, server is what? Basically the database engine, which is the main core database software that you have running on your system. Okay, now if you ask me that why is it done in this manner, I am only doing the SQL, but then why this client and server? The main idea is because you don't have in mind all of the data at any point, right? You have a data dump, you are putting the data into the system. There is a engine which is depending upon what you ask, it optimizes the search, and optimizing the search, it results the appropriate data. So that means you are asking something and there is some part within the system which is answering to your demands. So that's why, due to this asking and answering kind of nature, querying kind of nature, right? When you write a Python code, it's not like that. You are not querying anything. You know everything. You are writing a Python code and you are expecting your system to run that code. There is no asking and getting answer, something like that is not involved. But here you are asking, querying a part. And that's why we make it in the form of a server-client architecture. Now, why I discuss this topic? Because your PostgreSQL and MySQL are client-server architecture database. And client-server architecture database works in a fashion like in this fashion, and this helps them to maintain a lot of heavy, difficult tasks like transaction control, concurrency control, like the heavy things, like heavy duties that they have to do to make a proper database system, right? So they basically are able to do that because they are in the form of a client server model. Now I am not going into the details again, it will be very intensive, but the idea is this is done in a client server model because of handling heavier tasks like transaction and concurrency control, locking, consistency issues, many other things. But SQLite, okay, SQLite software is something which is a file-based system. Fine, just 1 second. So your SQLite, and that's why I call it light, it is something which is a file-based architecture. So PostgreSQL and your MySQL are client server architecture. SQLite is your not paper, actually documents based or file based architecture. File based. Now, since SQLite is file based, that's why it is not able to do a lot of heavier task or performance intensive task, right? So when you need a performance intensive database where there is a lot of data, so what that means is when huge data set, comma, multiple user asking or accessing, trying to access the data together, right? So you can understand this from the why server and client architecture serves this purpose in a better way. So when you are querying something like recently everyone is basically doing that, what do we call that, image generation, that animation image generation on your LLMs, ChatGPT and all of that. specific studio style of image. What do we call that? Can someone tell me? Some studio, right? Ghibli studio or something we call it, right? So everyone is basically doing that. Now the thing is, all of the people are basically querying to generate that kind of image. So many people are basically trying to access the same utility, but that server is, let's say, not that much. So a single server is handling many requests. So a client server architecture can handle multiple requests at the same time, but a file-based system cannot handle that. So when you have multiple users trying to work on the same database, then a client server architecture will function in a much better way, and a file-based system will not be able to work. So when the data set is huge, or there are multiple users trying to access the data set or the database concurrently or at the same time, or let's say when you have some performance issues. Performance means speed, the how at what speed the transactions are being executed, right? Performance, like throughput. All we will discuss these terms in later weeks. So when all these things are considered, then the SQLite, which is basically a file-based system, will not be able to perform, and multi-user will not work in SQLite at all, right? So that's why this file-based architecture doesn't work. But since client-server model inherently addresses multiple user issues, that's why, and there are also details which will show you, which will prove to you that it can handle huge data set, and also it has better performance. So client-server architectural model like PostgreSQL and MySQL are better for this heavy-duty kind of stuffs. When you work on a real application. But let's say if you have to work on an application like which is very limited, let's say you have an electronic device. Let's say you have a washing machine, and washing machine you want to in the washing machine, you are basically a company which creates washing machine, and you want to have a log inside the machine which will tell that at what temperature, at what capacity, and in which setting, at what day and at what time a wash cycle was done. So this kind of information you want to maintain inside the washing machine. Now, do we have an operating system inside the washing machine? No. Do we have a processor and intensive processing unit inside a washing machine? No. We don't have any such things, right? But still I want to maintain a data set, or let's say this kind of log. So then inside the washing machine, I cannot have a PostgreSQL or MySQL database system installed, because in order for PostgreSQL or MySQL to run, I will need an operating system. And that's why I did the discussion at the beginning of this session, that in order to have your DBMS running on your system, you must have an operating system, right? And this is the background story also we learned, that why we need an operating system, right? So PostgreSQL, MySQL is also an application software. So again, it has to be loaded into the RAM, and all those things that we discussed will happen, and that will be taken care by the operating system. So since operating system is involved, but in washing machine, there is no Ubuntu or Linux or whatever, or your Windows or anything, or your Mac. So inside the washing machine, if you still want to maintain a data set or database kind of system, so in that kind of application or that kind of specific electronics, SQLite will be considered, because it is a file-based system. Since it is a file-based system, it only will be required to read and write into a file. Okay, so then you do not need an OS or anything. So in embedded systems, in electronics, small electronic gadgets, in all those things, you use SQLite if you want to maintain a log recovery or log kind of manner, logging, right? What we call logging. Those kind of application SQLite are used. And in main DBMS work, where you are actually doing database stuff, maybe enterprise data, maybe some organizational data, maybe some scientific data, or maybe some research work, or whatever, maybe some corporate data. When you are doing with stuffs like this, then you do not use SQLite, which is basically a file-based system. Rather, you use PostgreSQL or MySQL, which are client-server architecture model. Now, again, if you ask then why we are learning PostgreSQL and not MySQL, then no need to go into that details, because basically you understand this PostgreSQL addresses some performance issues much better than MySQL. So once you go into the advanced level of DBMS course and do some DBMS work, you will understand those points, that where MySQL is lagging behind and PostgreSQL is a better choice. Okay, but PostgreSQL, MySQL are similar kind of things. SQLite is completely different, and the utility of SQLite is somewhere else. Right? If you see the SQLite website, it will say that SQLite is not a competitor for PostgreSQL and MySQL. It is a competitor for fopen. Fopen basically file open function in C language. So in Python, open function. So that's what it says. So basically, you can understand where we need lightweight system without maybe OS. Then in that kind of environment, SQLite is used a lot. Fine.
Understood, sir.
Sure.
So, sir, there is one more term which is MongoDB. So, little bit information about it.
Okay, so MongoDB is something which is completely different to the database that we will learn over here. MongoDB, with little bit of it we will touch in the last week. So what MongoDB is an object-oriented database. Now, what is an object-oriented database? We see the fundamental idea of the normal SQL-based databases are relational database, and that's why in week 2 we will get into the relational database, and I already gave you a flavor of it. That all of our operations, all of everything that we do will be based upon relational algebra, relational operation like set difference, set intersection, union, Cartesian product, and all those things, right? So tables are relations and data are basically ordered pairs, and we will do all the operation on the basis of this. Now MongoDB is something which is not a relational database. It is something which we call object-oriented database. So the main essence of data stored inside a MongoDB database is not in the form of a relation. The operations that you do on the data are not set operations. They are normal operations, something else. Okay. So the way of functioning, the way the database engine, the database internal works in a relational database is completely different, and it is based upon relational algebra. Whereas in an object-oriented database, it is somewhat like your Python dictionary kind of. So if you want to store data in Python, dictionary is a very good tool for doing that, right? Because you can just write the key and you get the value part of it, key value pair. So you write the key, okay, what is the value corresponding to this key? You get the value and then you do the work. So key value pair of storing data is a very good way of storing information in Python or in any modern programming language, right? Which is basically the dictionary data structure. So MongoDB is kind of based upon that kind of model where you basically store any data under a particular identity. That okay. So let me just state in this manner. Let me give a comparison. You will understand it a little bit. Since this is week 1, we cannot delve into the details of it, but the flavor is, let's say I ask you that two comparison relational data, a relational DBMS, and another is object-oriented DBMS. Object-oriented DBMS. Now this is your MongoDB, and this is your Postgres. Fine. Now, if I say that I want to store that same student details of BSc degree students, got the point? BSc degree students. What will be the idea of relational database system? Most of the time, that I will have a table, and inside the table I will have fields related to the students, and then I will have the data corresponding to each student over here, right? So the main idea is at first you have to draw the table. So the table is important, right? Table is the main thing, and inside the table you have the data corresponding to each student. In an object-oriented database, you focus on the object first. So in this case, your students are the object. So let's say here I have Raj, here I have, let's say, Feynman, here I have, let's say, Boltzmann, and here I have Turing. So I have these 4 people, and here the main thing is, let's say, I mean some scientist, let's say database or table, scientist table. So here the table is the main thing. Scientist is basically a relation or a table. Inside that we have data where corresponding to each person data is there. This is how the things will be stored. In an object-oriented database, we will have the main focus is on the object at first. Object at first means on the persons at first. So here we will store data on Raj, Now the details of Raj will be given like in this dictionary format. You will have key value pairs, some key and then some value, then again some key and then some value, like this. And then I have Feynman, and then I have key value pairs, okay, like this, dot dot dot. So there will be no such thing as separate table. Now if I need some information on Feynman, I will say just okay, Feynman, whatever, put the key over here and I will get the value, right? So the focus in an object oriented database will be based upon the objects, and the focus in a relational database will be based upon the relation on, or the table, and the instance, that is basically the rows of information, will be part of the table. Okay, so this is how, and here the values, basically the rows of information in this place are basically the values in your object, I mean this dictionary representation. So these values will be a part of each of the element here, or each of the object here. So these are the objects. This is what we call objects. So Raj, Feynman, all of these are objects. And that's why we call DBMS, MongoDB is an object-oriented database, because the primary concern, or the way the data is represented, importance is given to the objects, importance is given to the person, and then we have a dictionary kind of storage of data. This is how the thing is there in MongoDB.
Understood.
Okay. Okay, this is a kind of a flavor of it, but obviously there are a lot of internals as well, and yeah, so we will. So that's why you can understand. So since we are not storing in the form of that kind of relational tabular or structure, you can take tables of it. You can create a, let's say, put it into a list and call it a table, but that will be separate. Here the table is completely separate. Once you go into relational algebra, you will understand that these tables are just not the table. All of these are relation. And if you do Cartesian product, that means, let's say, scientist cross student. So there is a student table and a scientist table. So it will essentially mean you will take each element of the scientist table and put it into the ordered pair with each element of the student table, just like you did in relational calculus, Cartesian product, all those things, right? Not relational calculus, relational algebra. So that's why the functioning of relational database is based upon relational algebra. The functioning of object-oriented database is not based upon any relational or mathematical algebra. It is based upon, I mean, normal storing data in the forms of object in a dictionary kind of structure. Okay, but both of them have advantage and disadvantage, and this is very good for unstructured data, right? Unstructured data means what? Giving you a little bit of more example. So let's say scientist table. I have name, ID, and all those things. So if I want to put information about another scientist, so let's say Jagadish Chandra Bosu, JC Bose, right? I want to put the information about him. Then I need to fill up the details in each of the column. Okay, or I must conform to the needs of each of the column. I cannot say that, okay, so for Feynman I have name and let's say university associated with number of doctoral student and number of patents. So these are the fields. And I cannot say for Jagadish Chandra Bosu, I will store the fields as not the name. Name will be there, but current university, number of doctoral students, number of patents, all these things I will not store. I will store where did he study in his childhood, what is his current educational qualification, and what is his current salary. I cannot store some other field inside the same table corresponding to a person who is a part of that table, right? So what I mean is the data that you are storing inside a table, each row should be following the attributes that are maintained on the table. So it cannot store for one row it is different from other row, for other row it is something completely different information. You cannot do it like that. So the information stored is a structured information, but in dictionary there is no structure, right? No one is saying you that, okay, for Feynman you have to follow the exact scheme that you have followed for Raj or someone else. For Feynman you want to store anything else in the key value pair, store whatever you need. Raj, you want to store something else in the key value pair, stored whatever, like Python dictionary. You can store anything you want. So that's why this is unstructured. So the data or information that you store has no specific structure which is there. Okay, unstructured. What, I don't know what I wrote while talking, but anyway, so this is unstructured data, this is structured data. So some cases you need this unstructured way of storing information. In those cases, object-oriented databases are much better. And there are further points, but this is the basic difference. Okay.
Okay, thank you, sir.
Yeah. Fine. So anyone with any doubts in week 1, anything else? Week 1 is easy. It's basically your motivation for the subject DBMS, that what we will learn, how we will learn. But if you have many doubts and not understanding a lot of things, the idea is, because week 1 is basically telling you the what we will learn in each week. So once we go into the weeks, we will understand each topics in detail.
Excuse me, sir. Sir, can
Yeah.
you tell about atomic values and atomic properties? There is an atom something.
Sorry, can you repeat once again?
There is a thing called atomic values and all the things, sir, in week 1.
Atomic values.
Hmm. Like in assignments I've seen, and I have read that atomic properties, those things. I haven't understand.
Atomic means, I think, okay, so in which context, but atomic basically means, as I told in case of transaction also, atomic means something which cannot be broken down into parts. So what I mean is, if a transaction or a block of code, like here we discussed, that if I have this block of code over here in SQL, then this whole thing will be executed. This whole thing, either this whole thing will be executed, or nothing will be executed. If something happens in between, if there is a trouble in between, then everything else that is executed till this point will be reverted back. It will be reverted or undone. So this feature is called atomic. This feature is called atomicity or atomic execution. And this is in terms of transaction. Atomic means this. In terms of data type, atomic means which is not a complex data type. So let's say I say that first name. If I say name, okay, name. Now name can have first name and last name associated with it. First name and last name. So you have two different fields constituted together in the form of one attribute. So I can say this is a composite attribute or composite data. I mean composite attribute. Yeah. And each of this is what we call atomic attribute. Why? Again, because atomic means something which cannot be broken. Now name can be broken into first name and last name attribute, but first name itself is one attribute and there is no further subdivision of it. That's why we call it atomic attribute. So these are the two aspects that we will learn the word atomic in DBMS. But if you are telling about something else, some other context, then can you point me where can I find it? You said in assignment. So which assignment? Practice assignment?
1.5, sir. Yeah, sir.
Okay.
No, sir. Activity question 1.5.
Oh, okay.
There in options I've seen, sir, like atomic. 1 minute, sir. I'm also checking.
1.5, right? 1.5.
1.5 second question for.
Okay.
But in my question, it is different, sir. Like it contains atomic values. Like
Let
maybe
me check. This is term 2, right? 25 term 2. This is correct only. I think it is. Is it done in a random fashion? I mean, it is jumbled. Let me check all the question. Atomic.
It is the question is about is that true about object relational data model? In that first option is. Can I share my screen, sir?
You can tell me the question. Can you read the question?
Yes, sir.
Go ahead.
The question is, which of the following is or are true about object relational data model?
Okay.
The options are: it contains atomic values, it was originally intended as a document markup language and not as a database language. The third
Okay. So
option,
here
it provides
is that thing that I told. Atomic value means in this case.
Okay, yeah, I got it.
Right, you got it right. I don't know where
Yes.
I wrote it, but yeah. So basically, atomic value means basically you have a data type or an attribute which is not broken into, which cannot be broken further into. I mean that first name, last name example that I told you. Okay. So yeah. So there will be two different ways atomic will come in our context. First is your transaction, and that will be incomplete and complete execution, and other will be your data type. Data type means your basically these attributes that we just discussed, your first name, last name, that the table head column, right? So that can be atomic and that can also be composite. So if 2-3 columns together constitute a column, right? So let's say address. You say you have an address field, and inside that address field, you say that this is the house number. One column will be in the table house number, other column will be street or lane, another column will be your let's say city, another column will be your town. Sorry, not town, your state and PIN number. So let's say these 4 or 5 columns together, there are 5 columns in your table, and you define, while defining the table, you call that, okay, I have a name for each of these column, like house number, street, etc. But together, all of them will have one name, and that will be, let's say, address. So in the SQL query, if I write that, give me the house number of so and so, then only the house number column will be activated and the house number will be returned. But if I ask that give me the address, while writing a SQL query, I write give me the address, then the whole address, the house number column with the lane column, city, town, state, all the columns will be activated and the whole thing will be returned to me. So I don't have to write give me the house number and the street and the city and the state. I don't have to write all the column names in order to get the result. I can write give me the address, then all of them will be activated. Right, so that's why we make a composite name for each of the for a group of single columns, and that's where we call composite values or composite attribute. And single non-breakable columns are called atomic values or atomic attributes. Okay.
Yes, sir, thank you. Sir, another session is going on, sir. Mad one session right now.
Go ahead. Anyway, this is over. So
yeah, thank you, sir.
Those of you who want to leave, please leave. And yeah, so maybe from the next week, mainly we will discuss a lot of detailed, more concept-oriented stuff. And this is kind of an overview of what we will be learning as a part of our course. And that's why if you are half partially understanding some things, not understanding something, it is completely fine, because we will be learning them later as the weeks come. Right? So any doubts, any further doubts? Otherwise we will close. Okay, fine then. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Go ahead.
Great
Yeah.
session.
Thank you.